Okay, we're going to start theoretical probability today. The rest of the chapter will focus on theoretical probability. So in order to get into some of the more in-depth theoretical probability, we have to understand the basics of finding some simple probability and how to get the total number of outcomes for the bottom and all that. When evaluating probability, it's important to know or be aware of all the different things that can happen. These are called outcomes. Every little thing that could happen when you do something. Now, it could be as simple as when you flip a coin. What could happen? When you flip a coin, what could happen? It could land on heads or tails. So you have two different outcomes. That's it. You have two different outcomes. It could be a heads, could be a tails. Any single outcome or combination of outcomes is called an event. So when we're looking at these, all of the outcomes, this would be your bottom number in your ratio. And the event, this would be the top number. A list of all the outcomes is called the sample space because it's a sample of what could happen. There are two basic ways to find the probability of a single event. And we will go through both of those basic ways today. The first basic way is by counting. You can count to find the probability of a single event. Here's an example of a probability of a probability question with a single event. In an experiment, a number cube is tossed and a coin is flipped. What is the probability of rolling a 6 and getting a heads? Right, if I were to list this out in probability format, this is how we would say probability of 6 and a heads. That's what it would look like. So we're going to count to find that probability. In order to do that, the first thing I have to do is list the sample space. So what are all the different outcomes? Well, what's the first number I could roll? 1. And then I could get, when I flip the coin, what could I get? Heads. Or I could get a 1 and do what? I could get a heads, 2, and get a tail. So do you see what I'm doing? I'm just listing all the different numbers. Running out of room. Of all the different outcomes I could have. Oh, 8 for each choice. All right, so there's my sample space listed. What were the total number of outcomes there on that page? How many outcomes did I have? 12. So I have 12 outcomes. Would that be the top or bottom number? Bottom. The bottom number is always the total. So really we should list this as that, right? What were the number of favorable outcomes? Now what does that mean, favorable outcomes? It's what I want. What did I want? What did I want? 6 and a heads, right? How many times do you see that? Just once, right? So right there. That's the only place I see where I have both the 6 being rolled and I flip the coin and getting heads. So it happened only once. So what was the probability? 1 in 12. And how did I get that? I counted. I counted to get the total number of outcomes, and I counted the number of times I saw my favorable outcome, the one I was looking for. Now this is not a probability problem, but it's going to lead to something. A pizza parlor offers 3 different sizes of pizza: large, medium, and small. It also offers 4 toppings: cheese, pepperoni, sausage, and onion. How many different pizzas with 1 topping are available? More than that, actually. Couldn't I get a small cheese, small pepperoni, small onion? Oops, let me do it a different way. I could get small cheese, medium cheese, large cheese, correct? Couldn't I get small pepperoni, medium pepperoni, large pepperoni? I could get small sausage, medium sausage, large sausage, or small onion, medium onion, large onion. So how many different pizzas with 1 topping available? 12. That would be our bottom number if we wanted to go and say, hey, if all those boxes were just lying there and you had to pick one, what's the probability of choosing a medium pizza? Yes, which would be 4 out of 12, which would be 1 in 3 probability, right? Because you reduce it. What would be the probability of choosing a small cheese? 1 out of 12, right? Well, this took a little bit of time to list out the sample space. That's what this is. This is my sample space right there. Took a little bit of time to list all that out, didn't it? Wouldn't it be nice if we could take these 2 numbers, these 2 things, and just come up with the bottom number? If there were a shortcut, it would be nice. We're going to work on that. What? Yes, there is a way, actually. We'll work on it. Okay, so the first way to get your probability is by counting. There is another way. It's called a tree diagram. And what a tree diagram is it's just a more organized way to list your sample space. You're still kind of counting at the end, but it's an organized counting. No, this is more just a modification of the first. The second one we're still working on. This is just another way to do what we were just doing with the counting, but to do it in a more organized way. Because when you start to get 3 events, then it starts getting more difficult. Coming up with all the to list out the entire sample space. Okay. 3 coins, a penny, a nickel, and a dime are tossed at the same time. What is the probability of getting heads on exactly 2 of the coins? Now, does it matter which coin is which? No, why not? Yeah, and why doesn't it matter? Because when you flip any coin, the outcomes are heads or tails, so it doesn't matter. But that's one of the things they'll do to try and confuse you. Oh, well, the nickel's got to be, and some students will be, oh, the nickel has to be first. Well, if the nickel's first, it would be different than if the nickel were second. Well, no, it wouldn't. It's heads or tails. So just something to keep in mind. When I flip the first coin, whatever it is, what are the outcomes for the first coin? Heads or tails? Now when I flip that second coin, let's say I get a heads for the first one, what are my outcomes for the second coin? Heads or tails, yeah. So what I'm going to do is I'm just going to draw 2 lines to connect the 2 outcomes for the heads. Well, wouldn't I have 2 outcomes if I got a tail on the first one too? Yeah, and wouldn't they be the same? They would. I could have heads or tails. Now, what's going to happen for each one of these now? With the third coin, there are how many outcomes for each one of these? 2 more, yeah. Each one of these, there are 2 outcomes. You get a heads or tails. So you see how with each event, I'm listing the number of outcomes, or listing each outcome. This is the sample space. I've listed it out. It's nice and organized now. How many total outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8. So if I want to know my probability, I'd count it. This is an easy way to count to get the total number of outcomes. It'll always be the number of letters you have, or letters and numbers all the way at the end. There's your total number of outcomes. Now what I want to do is I want to figure out the top number. No. There are 8, 2, 1, 2, 3, 4, 5, 6, 7, 8. No, you just count the end. Because the reason why there are 8 of these is because I had 2 here, and each one of these had 2. We'll get to a shortcut to getting the 8 in a minute. That's the other way to do it. All right, what is going to be give me my top number? Every time I see what? 2. What am I asking to find the probability of? I'm asking for the probability of a heads and a heads out of the 3. Well, where do I see it? Well, I see it here with heads, heads, tails, right? Isn't that 2 heads? And heads, tails, heads, that gives me 2. Tails, heads, heads. Anything else? Is there any other combination? No. So what's my probability of getting exactly 2 heads? 3 and 8 probability, because there are 3 different cases. So there's 3 and 8 probability. Now what I was mentioning earlier, the other method to find probability is, wouldn't it be nice if there were a shortcut to somehow get to that bottom number a lot faster than listing out the entire sample space? That would be great, wouldn't it? Like if I could take, I have 3 different sizes here and 4 different toppings. What could I do with these 2 numbers maybe to get to 12 more quickly? Multiply, yeah. Same thing here. To get faster to the 8, I have 2 outcomes here, 2 outcomes here, and 2 outcomes here. What can I do with those 3 2's to get to 8? Multiply. When you multiply the total number of outcomes for each individual event, what you are doing is you are using something called the fundamental counting principle. The fundamental counting principle says you take the number of outcomes for each individual event. If you multiply all those together, then you get the total number of outcomes, period. Like if we wanted to do a probability based on the number of the different kinds of genes, men's genes that the Gap sells men's jeans in 37 different sizes, 10 different fits, and 8 different colors. How many different kinds of jeans do they sell? Yeah, multiply all those together. 37 times 10 times 8. 2,960. That is a lot of genes. So what we could do for a probability problem is saying if you had all of them sitting in a room and you walked in blindfolded, what would be the probability of choosing a size 32 slim fit antique wash jeans? It'd be 1 in 2,960. So these, yeah. Slim chances or slim fit, or both. So this is the fundamental counting principles where you multiply all of the individual outcomes to totals for each, and that gives you your bottom number, give you your total. This is basic theoretical probability. This is what we'll be doing the rest of the chapter. This is in your, this purple box is in your book. The number of favorable outcomes, that's sometimes confusing. What is another way to phrase number of favorable outcomes? What you want. That's what they're asking for, right? That's what they're asking for in the question. That's another way to phrase that. What you want. My gosh, the board is off. What you want. The bottom is still the total. So here's a basic theoretical problem. Theoretical probability. A card is picked at random from a set of numbers, with a set marked with numbers 1 through 12. So they're just cards with 1 through 12. How many outcomes do I have? 12. Notice how I always find my total, my bottom number first. Have you guys noticed that? I've been pretty consistent with that. So I have 12 different outcomes. Now I can worry about finding the probability of whatever they're asking for. By finding just this bottom number first, now I can really just focus in on this without being distracted. Find the probability of choosing a card of an odd number greater than 5. How many odd numbers are greater than 5? Close. But less than 12, right? Because the cards only go up to 12, so yeah. How many odd numbers greater than 5 but less than 12? 3. So you have 3 and 12 probability, which is actually 1 and 4 probability. All right. Any questions? That's the basics of theoretical probability. It'll get harder starting tomorrow when we do compound events. 1 to 19. 1 to 19 all. Pages 160 and 161, 1 to 19 all.